Let's start. So today's agenda, let me write down. Okay. So today we are going to discuss about what is simple linear regression. So these are the agenda that I have set as part of today's class. We'll discuss each and everything. Okay. So first we'll just go for a recap or revision that we have discussed in the last class. Then we'll see what are the different assumptions of simple linear regression. Okay, these are the points we'll see. Then we'll talk about hypothesis testing in linear regression. Then building a linear model. What is linear regression? Simple linear regression. Then machine learning terminology, formulas. Then loading data set, price, data set. Loading house price data set, then creating scatter plot using matplotlib, model training, predict price of a home with the area that we'll discuss one by one. So basically we'll take a problem statement, we'll try to find out the y value, nothing but the target value. Okay, then capture the coefficient from the linear regression, capture the intercept from linear regression, then prove the result. Okay, I'll prove the result. Fine. So let's go for recap. So what we have discussed in the last class. So last class we have just started with the machine learning. We have seen what is machine learning, the entire AI universe and all. Then we narrow down to regression. Then again coming to regression, we have seen there are basically three different type of regression. Let me draw quickly for a quick recap. Okay, regression model. Okay, regression model. Then basically we have seen it is of three types: uh, linear regression, non-linear regression, and polynomial regression. Now we have seen compared to linear regression, non-linear regression and polynomial regression are not that much popular or not industry used. So this is just for the knowledge check we have written, but nowhere people are using all these things. Okay, generally people are dealing with a linear regression. Now coming to linear regression, again it is of two types: simple linear regression. In short, I am writing LR. Another one is called multiple linear regression. So as part of today's agenda, we are going to discuss about simple linear regression. What is the date today? 24 4 sorry 2 2025, right? Now the multiple linear regression we are going to discuss in the upcoming class, in next class. So next class will be when third, right? So it will be March 3rd, 3/3/2025. Okay, we'll discuss in the next Monday. Fine. Now let's see what is simple linear regression and all. Okay. So before that, I will talk about all the assumptions that before proceeding for simple linear regression, we'll see what are the different assumptions we are considering, like linear relationship between x and y, then error term as normally distributed, independent of error term, constant variance and all. Each and everything we'll see. Then we'll talk about hypothesis testing in linear regression. Then we'll go for how we are going to build a linear regression. Okay. Then I will talk about in depth, like what is exactly linear regression, what is simple linear regression. Then what are the different? I will take a problem statement today. I'll try to predict. Okay. I will train it. Then I'll predict its value. then I'll prove it. What the prediction I'm getting if I do manual calculation by finding intercept and coefficient, same result is matching also. That will prove it as part of the last one. Okay, we'll see one by one. Now let's talk about different assumptions of simple linear regression. Assumptions of, let me scroll off, simple linear regression. Okay, let me go to my PPT. Let me share my PPT with you. There I can explain directly. Okay, so let me stop sharing the. Yeah, you can see. Before proceeding to the Python code, it is crucial to address a key aspect of linear regression, the underlying assumption. What are the assumptions? We'll see one by one. When constructing a linear model, it is assumed that the target variable and the input variable have a linear relationship. Are there any other assumptions that need to be considered? Let's try to see the answer. So in addition to this assumption, we will also have to follow some other assumption. So what is the first assumption? There should be a linear relationship between x and y. What does it mean? That we will see going forward. Now, when you are drawing conclusion about a larger group or population based on a smaller representative group or sample, simply assuming a linear dependency between variables is not enough to extend your sample finding to the population. In order to make inferences, it is necessary to have certain assumption in place. Let's examine the significance of each assumption individually. Like as I told you, there should be a linear relationship between x and y. What do you mean by that? You can see. Even if a same type of plot also we have seen in the last class, right? I have shown you a plot between linear regression, I mean simple linear regression, multiple linear regression, non-linear regression, and polynomial regression, right? Now here I have derived two different things, linear pattern and non-linear pattern. You can see guys. The first one is the example of the linear relationship between x and y. So you can see when x increases, y is increasing in the same ratio also, same percentage also. That's why the straight line is coming. Why? Because this is linear pattern. But here, in the second diagram, the relationship between x and y is not linear. It is non-linear. You can see. That's why a little bit curvy. Okay, little bit curvy. We have seen also last class, right? If it will be polynomial, it will be too much curve, like kind of exponential. But this is non-linear, not linear. So this is not a straight line. You can see the red color mark is not a straight line. So you can see when x will increase, y will increase. No. So when x will increase, y will increase at a certain point. Let's say up to this point. Then it will reach in certain point where x will be increasing, x will be constant, but y will be increasing, something like that. You can see if you go up to like this. But here, as long as x is increasing, y is also increasing. X is increasing, y is increasing. X is increasing, y is increasing. Keep on like this. Okay, this is the first assumption. Now, coming to the second assumption. Let me maximize it. The error term are normally distributed with a mean 0, not x comma y. What is that error term? Last class we have seen. The difference between y actual and y predicted. That is yi minus y predicted is equal to ei. Okay, that is the error term. So it is telling it should be normally distributed. What do you mean by normal distribution? You can see error term normally distributed. If I want to draw in the xy axis, it's a kind of bell-shaped curve, or a kind of, I can say, Gaussian curve. You might have seen in the mathematics in the intermediate class, right? So if I will draw a curve like this is the middle one. Whatever the error term is present in the left hand side is same as the right hand side. You can see. Okay, this is the distance same. This is this is little bit kind of I think diagrammatically error, but it will be same kind of things. You can see. So it is normally distributed. But in case of right hand side, guys, you can see this is not normally distributed. What does it mean? First it will go up to this level, then increases, then decreases, then increases, then increases. Here increasing percentage also not same, and decreasing percentage also not same. But here you can see for from first pillar, whatever the percentage is increasing, in the second it is increasing same. Then while decreasing also it is decreasing, decreasing, decreasing. Means first it will increase, then it will decrease. The curve is like that. But here you cannot give guarantee. It will increase, then decrease, then increase, then increase, then there may after that decrease also. That's why error term is not normally distributed. It is abnormally distributed. Okay, this is the second assumption. Now coming to the third one, you can see independent of error term. What do you mean by independent of error term? You can see it's written no visible pattern. Error term independent. So there is no visible pattern. Just data is present in the scattered manner in the both positive x-axis, sorry, positive y-axis and a negative y-axis and all. But here you can see visibility pattern error term is independent. So dependent. Why? You are able to see clearly there is a pattern. So first it will go increasing, increasing, increasing. Then after a certain point, it is keep on decreasing. But here you can see it's decreasing, decreasing, come to a negative minus e, then it's going decreasing, decreasing. When error terms is keep on increasing, then decreasing. First here decreasing, then increasing. But here you cannot draw a such type of relationship for the error term because data is present in the scattered manner. You can see it's written the same thing. The error term should not have any mutual dependency, such as it's a time series draw data where the next value is depend on the previous one. So the second one is a time series data. Why? Because based upon the timing, because the next point is depend on the previous one. Next point is depend upon the previous one. Next point is depend upon the previous one. But here you cannot draw such type of diagram, dependent diagram. Clear, guys. Now moving to the next constant variance of error term. That is called homoscedasticity. What do you mean by that? You can see the variance should remain constant and not increase or decrease as the error value changes and should not follow any pattern as the error term varies. Here you can see, guys, whenever this is a linear diagram, right? The error term is the data, whatever is present in the scattered manner, just surrounding this red color line, you can see the variance is, universally distributed. Means the distance between this point and this point, this point and this point, you can see this same just a borderline. But here you can see it is like kind of converging. First it narrow down, then slowly converge. You can see the distance from this line to data point is whatever that is less than the distance from this line to this data point because it's too far, right? Too far, too far. You can see kind of converging line. But here is throughout the line is same. Let's say the distance from this data point 2 centimeter, here also 2 centimeter, here also 2 centimeter. But here it may be 2 centimeter, now it is 4 centimeter, now it's 5 centimeter, 6 centimeter, and so on. Clear? So this is called homoscedasticity. This is homoscedasticity. This is a heteroscedasticity. Means keep on varying. You can see it's written here. Changing variance, heteroscedasticity. Here. Here constant variance, homoscedasticity. So according to our rule, if we need to implement simple linear regression, then it should follow homoscedasticity, not a heteroscedasticity. Clear, guys? Any doubt so far? Any doubt so far? Now let's move to the next one. Next one is hypothesis testing in linear regression. Okay, let me come back to my whiteboard, then I'll explain this one. So guys, till this point, any doubt? One more time. Okay, let me repeat one more time. Okay, generally we have seen the equation of straight line is equal to y is equal to mx plus c. So here m is nothing but slope, c is nothing but my y-intercept or constant I can say. What do you mean by that? If I draw a straight line, you can see this red color mark. If I extend it where it touches to y-axis, so this distance 0 to means origin to that distance is called c is nothing but y-intercept or a constant value. So for example, I have given a line, straight line. I've given two different points, x1, y1, x2, y2. What is the formula of getting slope? M is equal to y2 minus y1 divided by x2 minus x1. So in the last class, you might have seen, instead of using M and C, okay, I'm using beta 1 and beta 0. So I'm just replacing M with beta 1, C with beta 0. Now my equation will be y is equal to beta 1 x plus beta 0. Now, as part of hypothesis testing, I'm just trying to play around these two values, beta 1 and beta 0. I'll try to find out the optimum value so that I can get the y value, and it will, when I draw it in the xy plane, it will give me a best fit line. Best fit line. Because x is given. So if I find a slope, if I multiply the x plus if I add the y-intercept value, then I'll get easily the value of y. Then I can draw a straight line, equation of straight line and all. Clear guys? Any doubts so far? What I'm telling is it same things or not? Before proceeding with the model building, there is a theoretical aspect that needs to be addressed. The significance of the beta coefficient. When fitting a straight line through a data, two parameters are obtained. The intercept beta 0, as I told you, that is C value, and the slope, that is beta 1, nothing but M. While beta 0 is not critical at this stage, because we know beta 0 always constant, because C value, right? Because whenever I draw a line, it will touch us somewhere in the y-axis, and that distance from origin is constant, same. So only the slope value is important for me. The significance of beta 1 needs to be confirmed. The question that arises is the beta coefficient significant? What does it imply? What does it mean by this? That we need to figure it out actually. Clear? Now let's move to the next one. That is, imagine you have a data set that produces a scatter plot as shown below. Let me maximize it. I hope all of it clear, right? Is it visible? Fine. You can see. Imagine you have a data set that produces a scatter plot as shown below. You can see in the next. After conducting a linear regression on the data set, the resulting line fit well to be displayed as such. You can see. So I am drawing a best fit line, kind of linear regression. Okay, it touches y-axis here. So this distance is called x. Now move to the next one. Let me explain what I'm talking about. Before interpreting the result of a linear regression analysis, it is important to assess the significance of the coefficient. In the case where the scatter plot of the data appears to be randomly scattered without any linear trend, running a linear regression will still fit a line to the data using the least square method. However, this line may not be useful. Therefore, it is necessary to perform hypothesis testing on the coefficient, that is beta 1, because beta 0 is not that much important for me. Clear? To determine if it is significant or not. To determine it is significant or not. It's important to have a strong understanding of hypothesis testing before proceeding. If you need a refresher, you can revisit the earlier. Okay, that is fine. Now let's see. You can see. Here I'm explaining in depth. The hypothesis testing start by assuming that the coefficient beta 1 is not significant, meaning that there is no relationship between x and y. I'm assuming. Okay, actually, as you have seen, we should assume that there is a strong relationship between x and y. But here, I'm just taking reverse so that I will prove it. Whatever I assume, that is wrong. Okay, so the null hypothesis is there that beta 1 is equal to 0. Why? Because it's not significant. And what should be the alternative one? And the alternative hypothesis should be beta 1 not equal to 0, means it has significant. But we have seen actually it is significant. But I'm assuming it does not have significant. And that I'll prove that whatever I assume that is wrong. That means it has significant. Are you getting my point? So if the null hypothesis is not rejected, it is suggests that beta 1 is equal to 0 and that is therefore not a significant part of the model. On the other hand, if the null hypothesis is rejected, it implies that beta 1 is not equal to 0 and the filter line is considered significant. Getting my point? Try to understand this point. Anyhow, I'll go to my whiteboard, I'll explain one more time. To perform the hypothesis test, the t score is calculated, which is similar to z score and is given by x minus mu divided by s by root over of n. Okay, I'll explain, nothing to be worried. Where mu is the population mean and s is the sample standard deviation. The standard error is obtained by dividing the sample standard deviation by the square root of the sample, sample size n. Okay, fine. It's just giving an example. Okay, let's go back to my whiteboard. I'll try to explain what are these points telling me. Second, third, fourth, fifth, and all. Okay, fine. Now, guys, as part of the assumption of the linear regression, what we have seen here, as part of the assumption, we have seen the first one. There should be a linear relationship between x and y. Correct? So when the linear relationship between x and y will come, it will come when I will write y is equal to, here, y is equal to beta 1 x and beta 0. And as beta 0 is constant term, so I'm not giving more focus on beta 0, constant term. Right? So I'm just focusing on beta 1. So that means beta 1 has contribution towards deciding factor, that is y. Why? Because y is equal to beta 1 x. And this is some constant term, right? Constant. Anything, let's say 5, 8, 9, whatever. That means y value not only depends upon x value, it also depends upon beta 1 also. Yes or no? For example, x value is equal to 2. What is y value? That depends upon beta 1. So suppose beta 1 is equal to 3, then 3 into 2, then y value is equal to 6. For example, it is same, x value 2, but beta value is not 3, it is, let's say, 12. Now y values keep on changing, it will be 24, right? That means y value not only depends upon x value, because here x value is same, but y values keep on changing. Why? Because my beta values keep on changing. So beta value having more significant. But I'm assuming, let's say it does not have significant. That means I'm assuming while doing a hypothesis testing. Okay, hypothesis. Okay, let me tell you what is hypothesis testing and all. So just some theoretical background, because anyhow you are hearing this thing first time, right? So hypothesis testing is nothing but a kind of testing which is we are doing or implementing the statistics analysis. Statistical analysis. Okay. It has a lot of other terms and all. I'm not going in depth because we are not here to learn statistics and all. Just I'm giving some brief idea. So there are different parameters. There is something called Z test. Okay. T test, P value, probability value. Okay, ANOVA test, chi-square test. Okay, there are a lot of advanced technology are there. Nothing to do. These are the advanced thing and all. Okay, so how we are testing? When we are testing, means we are trying to find out some value, Z value, T value, more or less same. That like it's written, Z value is equal to or T value is equal to something. It was written like x minus. Let me see what is written there. Just 1 minute. X minus mu divided by s then square root of n, s then divided by square root of n. Okay, this is my t value. Anyhow, you no need to remember. Okay, for as I'm explaining, I'm just writing. So the t score value, right? So here mu is nothing but kind of, I can say, population mean. So mu is nothing but, let me write in a different color. Let me scroll off. Mu is nothing but N is nothing but number of sample, right? Number of sample. Okay, and S is nothing but sample standard deviation. Clear? Now, what is telling? Now, there are two different terms that will play around this hypothesis testing. That is, one is called null hypothesis, null hypothesis. First one. Second one is called just opposite to null hypothesis. That is called alternative. Alternative. Alternative hypothesis. Okay, null hypothesis and alternate hypothesis. Alternate, N-A-T-E, sorry, not N-A-T. Alternate hypothesis. Okay, what do you mean by that? For example, think about. I'm just giving a suitable example you can understand. You might have seen, you might have played cricket match, maybe in your childhood. Whenever we toss a coin, okay, generally opposite person toss a coin, we call either head or tail. Are you getting my point? For example, we have to call head or tail. For example, I am calling head. If head is coming, like there's a coin, okay, if head is coming, then I win. Then I will elect for batting. Or it's my choice, I can give them, okay, you go for batting, I'll do bowling. But it's a the call I will take first because I win the touch. Are you getting my point? For example, I win the touch. Let's say the opposite person, let's say there is a match, India versus Pakistan yesterday, right? For example, the captain of Pakistan, he threw the touch. Now the captain of India, he called, let's say it should be tail. Okay, now he got a tail, got a tail. That means India win the touch. Now India will decide whether I will go for batting or I will go for bowling. If they want to go for batting, happily they can go for batting, and Pakistan people will go for bowling. But if India people want no, let them give the chance for batting so that the score that they have made it will be in their control, right? So they will tell, okay, you people go for batting, we will go for bowling. So the decision will be taken care by the Indian people. Why? Because they win the touch. Similarly, kind of think about null hypothesis, alternate hypothesis. Means if you are calling, let's say top, head, and head will come means you are winning. If tail will come means this is wrong, null hypothesis. That means alternative will be winning. I'm getting my point. For example, India people call tail, but head came. Okay, head come. Then what will happens? If India people call and it head comes, then what will happen? Then that means Pakistan will win the touch. Then they will decide whether we will go for batting or not. Think about like this. Null hypothesis means I am assuming beta 1 having no significance towards deciding this linear value y is equal to mx plus c. But we have seen beta 1. But assume no contribution. That means beta 0 is equal to 0. If beta 1 is equal to 0, put like y is equal to a beta 1 x plus beta 0. If my beta 1 value is equal to 0, the entire term becomes 0. Now y value is equal to beta 0, but beta 0 is a constant. So that means it will be something like a flat constant. Or like, are you getting me? Because no changes, right? Whatever the value will come, it will be like x-axis. See, this is y, this is x. This is my beta 0, right? So beta 0 is equal to y means throughout this constant. That means this is kind of parallel to x-axis. It's not increasing like, y is equal to mx plus c. That means it's a negative thing. But I'm assuming, okay, let's say beta 0 is equal to 0. If beta 0 is equal to 0, what should be this is nothing but my null hypothesis. Then what's about alternative hypothesis? I am considering beta 1 not equal to 0. Not equal to 0 means it has contribution towards deciding y value, which is correct. Because we have seen y is equal to beta 1 next, in that beta 1 having contribution. That's why this y values keep on changing. Why? Because the beta 1 values keep on changing. I cannot say beta 1 having no contribution. That means actually this one is correct. But I'm assuming suppose beta 1 having no contribution, then alternative will be beta 1 is equal to 0. Okay, if I prove, see, now carefully, if I prove this assumption is correct, that means automatically this assumption will be wrong or not. That means it will be reject, 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 null, null, hypothesis, hypothesis. And what is this? This is accept, because it win, right? Accept, 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 alternative, alternate, alternate hypothesis. Guys, clear? Any doubt so far? Any doubt so far? Please, please. Now look at this. Standard. Okay, this is completed. Now go to the next one. Building a linear model. So to start, you will create a simple linear regression model using TB as a predictor variable, as it shows strong correlation with the target variable cells. Okay, so here I have taken one example for explaining purpose. While doing practical, I have taken house price prediction. Okay, we'll see two different data sets so that we get much clarity. The next step is to predict a train test split, which is an important step before building a model. I'll explain in the whiteboard, nothing to be worried. This can be done using the train underscore test underscore split function. Look at this function, train underscore, I can write, okay, fine. Here, train underscore test underscore split function from sklearn.model underscore selection library. So there is a scikit-learn library given by the Python. Inside that library, there is a method called model underscore selection, I can say. Okay, in that I can say this is a kind of parameter. Inside that there is a method called train underscore test underscore split. I have to use that function or method to achieve this thing. The function take as input the predictor x and the target y variable, and split the data into train and test set, with the training set size being 0.7 and the test set size being 0.3. Random underscore test argument is set to 100 to ensure product reproducibility of the result. From this point forward, it is recommended to always perform a trend test split using the sklearn library before fitting the model into any of that we are doing by default only, nothing to be worried. I will explain that. What is that? Okay. Now to build a simple linear regression model using a statistical modeling or statistical API, follow the below steps. Generally, we never follow generally. Okay, we follow the sklearn method. This one. I will explain in my whiteboard, and I will show you an example also. Okay, but there's another way also by importing a statistical model API we can do. So if I want to use that method, then what I have to do? I have to import a statistical model. That is import stat model.api as SM. SM is kind of alias name I'm taking. Statistical model. Is what I'm writing SM. Add a constant to the predictor variable train data. That is x underscore train underscore SM. So SM dot add underscore constant, that is x underscore train. Fit the ordinary least square OLS model. So LR is equal to SM dot OLS, that is y underscore train, comma x underscore train underscore SM. LR underscore model is equal to LR dot fit. Note, the R underscore constant command is used to include an intercept in the model. Without it, statistical model would fit a line passing through the origin by default. Okay, so what is talking about, we'll see one by one. Now, let's see. It's talking about this one. If I run this kind of code, while doing the practicals, I mean, ma'am will do the practicals, you can run this code and you can see, you will get a tabular data, I mean, the output like in this format. There is something called R square, adjacent R square, F statistics, probability F statistics, some value, exponential value. Then it is giving some value like P value is greater than T value, percentile ratio, coefficient, standard deviation, and everything is TB value, percentage is TB. Okay, let's now review the summary statistics produced by the model. Okay, so I'm getting such type of message. In this entire message, whatever the message I have highlighted in the red color kind of box symbol, that is important for me for doing the what I can say prediction. or I can say validation. So basically I am assuming or considering R square value, F statistics value, probability statistic value, then TB value. All this parameter is important for me. Now let's move. What is this F value? So I'm talking about this F value. What is this F value? What is this R square probability statistic that I have highlighted here? Just have a look. F statistics measure the significance of the overall model fit by determining if the fit was by chance or not. That means a p-value less than 0.05 indicates a significant model fit. Means if your p-value is less than 0.05, okay, then it indicates it is a best fit or it fits on top of that given data set. Now R square value shows how much of the variance in the data has been explained by the model, with a value of 81.6 percentage in this case being considered pretty good. R square value here you can see. R square value we are getting 0.816 means 81.6 percentage. So it's not a bad also. So higher the R square value is better the model I can say. Okay, because you know right last class we have discussed lower the error term is good because error value should not be more. It's error, error means should be less. Like for example, how many errors you are doing or mistake you are doing in exam, then you will get less mark, right? So less the error you will do in the exam, then more mark will secure. That is good or not? So less the error, good. R square means opposite. Higher the R square value is good. So we are getting 81.6 percentage. Some for other model we can get 95 percentage also, 96%. That's great. But if I tell, okay, R square value I'm getting 46%, is it a good model? No, this is not good model. It's below 50 percentage, not even 50% track also, right? That is what he's telling. Now you can see. Clear guys? Any doubt so far? Now, the p-value of the coefficient such as TB in this case indicate if the coefficient are significant. A practically zero p-value means the coefficient is significant. Why? Because whenever I'm telling zero is less than 0.05 or not. So till up to 0.05 it is good. So here in this case I'm getting 0. You can see where here I'm getting my TB p greater than t value. So here you can see the value I'm getting 0. Getting my point guys? Here 0 means 0 is less than 0.05, right? That's why it's telling the significant. That's great, good thing. Now next one. Other matrices in the summary statistics are not as important and will be discussed in the multiple linear regression. So other matrices, what I was saying, sir, why these are not important? These are not important for simple linear regression. This may be important for multiple linear regression. That's why we are not considering here. Okay, that we'll see in the multiple linear regression. Now, visualizing the regression line on the scatter plot of the training data is an important step in evaluating the model and all. Now, this is called statistical modeling, right? Whatever I explain based upon statistical modeling. Because if I write these 2-3 lines of code, import statement, then extend sm is equal to this one, then ols lr is equal to this 3 lines of code, then I'll get a output like this. Then that output I'm explaining what is talking about, what is R square, what is F statistics, what is this t value and all. Fantastic, right? Now we have seen there are two different ways. Another way is scale on, right? Because here I have shown you two different way, right? Here. Where is that? Where is that? Where is that? Yeah. Either escalon or statistical modeling. Now let's see the escalon method. Here is escalon. Linear regression using escalon, scikit-learn. Generally we call it as escalon or scikit-learn. And this is a library given by the Python. In our previous session, we worked with the statistical model library to fit a line through data and draw inferences. Another option for fitting a line and making prediction is scikit-learn or scikit-learn library, which is a great choice when you don't need the statistical part of your linear regression. Both statistical model and scikit-learn have their own advantages, and which one is preferred can vary in different industry. Because based upon a company, if a company tell no, we'll go for using statistical modeling, you go and use that one. If your company tell no, we'll go ahead and use the scale-on library, go ahead and use the scale-on library. Nothing, no problem with that. Okay. Now, it is therefore important for you to have knowledge of both the packages. So we have seen that one. Let's try to gain the knowledge about this. Next, we'll explore building a library regression model using scale law, scikit law. Okay, I'll show you the practicals how to do that, but I'm just showing you a sample piece of code. If I'm writing, so how I'm importing the statistical modeling, like this here, I have to import like from scalon dot linear underscore model, import linear regression because I'm going to use the linear regression here. I've shown you the first class, right? The example of a regression model, linear regression and all. Okay, now I'm creating the object LM is equal to linear regression. You know how to create the object in Python, right? Python class. So this is the class. I'm importing here. I'm creating the object of that class. Then on top of that object, I'm calling the fit method to train the model. That's why I'm passing x underscore train, y underscore train. So what is this x underscore train, y underscore train? That you'll get a clearer picture whenever I'll show you practicals in the upcoming, like within next 5 minutes and all. Clear, guys? Any doubts so far? Any doubts so far, guys? Please let me know. Okay. So we have completed successfully this one. Fine. Let's come back. So we have done building a linear model. We have seen two different ways, that is statistical modeling. Another one is called scalon, right? By using scalon. Another one is called statistical model. Okay. Now we'll talk about what is linear regression. The actual cinema starts now. What is linear regression? Okay. Then we'll talk about what are the next machine learning terminology. Okay, simple linear regression. Okay, then machine learning terminology and all. Okay. Okay. What is linear regression? Guys, this thing we have already seen in the last class. But okay, let me. I hope all of you are able to see my whiteboard, right? Okay. What is linear regression? Okay. If the relationship between x and y component is linear, means x here, this is y. We have seen the plot also. Kind of my graph is going like this. Linear means as x increases, y increases. X increases, y increases. X increases, y increases. This is called linear regression. Right? Again, as part of the start of my class, I have also given a quick recap. Part of linear regression also we have seen there are two different cases. That is simple linear regression and multiple linear regression. And we are here to learn about simple linear regression as part of today's agenda. And in the next class, we'll learn about multiple linear regression. Now let's guys see what is simple linear regression. What is simple linear regression? Simple linear regression. Okay. Now, what is simple linear regression? Guys, for example, if I tell the equation is something like this. Y is equal to mx plus c. Or you can see, like as we have maintaining beta 1, let me write down. That is beta 1x plus beta 0. This is my equation. Because here beta 0 is a constant term, so I'm not worried about that. Now y is it depends upon how many x factor, how many x term. That is only 1. That means as x value will increase, Means this is constant, right? So I can say y value will increase. If x value will increase, x value will increase, y value will increase. If my x value will decrease, then y value will also decrease. So I can say y is directly proportional to x. Yes or no? This is a mathematical equation that I am trying. Okay, here y value depends upon x. That is only one feature value. Only one feature value. F-E-A-T-U-R-E, feature value. Now, if I tell, for example, y will depends upon more than one term, like not only x. So y will depends upon, let's say, for example, y depends upon x1, x2, x3, x4, and so on and so on. Then, guys, what will do? So here I cannot say y only depends upon x. Y depends upon combination of both x1, x2, x3, and x4. In this case, the equation will be y is equal to, let's say, beta 1 x1 plus beta 2 x2 plus beta 3 x3, like dot dot dot, so on, plus at the end I have to add this constant term is nothing but beta. Yes or no, guys? So now here in this case, do you think that y value depends upon only x1? Y value depends upon only x1? No, it depends upon x1, x2, x3, x4, x5, and so on, like up to xn. Getting my point? And here beta 1, beta 2, beta 3, nothing but same slope, but generally it will be in this case beta 1 is equal to beta 2 is equal to beta 3, okay, up to beta n and all. Clear, guys? Any doubts? Any doubts? Any doubts? Clear. Now in this case, guys, my y term depends upon only one feature value. This is called simple linear regression. Simple linear regression. But here my y value depends upon more than x value. So this is not the example of simple linear regression. It is the example of multiple linear regression. So I've just given an overall idea for the next class. What is the equation of multiple linear regression? It's not y is equal to mx plus c. It's not y is equal to mx plus c. It is y is equal to, it is not y is equal to beta 1 x plus beta 0. It will be beta 1 x plus beta 2 x2 plus beta 3 x3 beta 0. Because y value depends upon not only x1 value, only one feature value. It depends upon more than one feature value. So I can write here more than one feature value. What is feature and all that we will discuss. This is a terminology. Okay, I will discuss feature values. Now, sir, you are using some bombastic word. What is this feature, and all? Lot of other things for the terminology. Could you please introduce this terminology with us? So that's why I've given a dedicated heading or subject line, that is machine learning terminology. Let's try to correlate. Let's try to make a friendship with the different terminology that we are going to use as part of machine learning. Then going forward, you will be not surprised by saying what is feature, what is prediction, what is evaluation, what is testing, what is training, and all. Okay, so let's try to introduce ourselves. Okay, or try to engage with a different terminology and all. Machine learning terminology. Okay, point 8. Machine learning terminology. Clear? Machine learning terminologies. Okay, fine. So for this, let me go to my PPT, then I will explain there. Guys, any doubt so far? Please. Okay. Below, guys. Linear regression. What do you mean by that? Whatever things I have explained till now or from last class, same things is written in a just document wise so that look and feel wise it looks good, and you can just have a look and you have a better understanding also. This is a technique and it explains the relationship between the dependent variable and independent variable. So what do you mean dependent variable? Which depends, that is y value. What do you mean by independent variable? Which is not depends, that is x value, because x value does not depends upon y value. Y value depends upon x value. Why? Because y is equal to mx plus c. So as x increases, y increases. X decreases, y decreases. So y depends upon x. So y is a dependent variable, but x does not depend upon y or any other things. That's why x is independent variable. Clear, guys? Any doubts so far? Any doubts so far? Now, types of linear regression. There are basically two different types of linear regression as I explained. Simple linear regression. Another one is called multiple linear regression. Right? Simple linear regression, and another one is called multiple linear regression. So as we are going to discuss simple linear regression, so let's focus on that. And the next class we are going to discuss about multiple linear regression. There I will go in depth and we'll see what are the different parameters and all together. Okay, so let me give just a definition. What do you mean by simple linear regression and what is multiple linear regression? Now it's written where you have only one independent variable. That means only one, means x, and one dependent variable. It is called simple linear regression. Anyhow, one dependent variable, that is always same. Now, similarly, in case of multiple linear regression, here also one dependent variable, that is y, right? Here also y, here also y. But what is written here? When you have two or more independent variable, that means not only one independent variable, that is x. Here, more than two or more than two, that is x1, x2, x3, x4, and so on. Then it is called multiple linear regression. So whenever I will give you the practical example, then at that time you will be 100% clear what is the difference between these two. Just for time being, you remember in case of simple linear regression, we have one independent variable, one dependent variable. In case of multiple linear regression, we have one dependent variable, no doubt, but we have two or more independent variables. Getting my point, guys? Any doubt so far? Any doubt so far? Now we can see. We'll talk about simple linear regression. Okay, you have only one independent variable and one dependent variable. It is called simple linear regression. Just sometimes before we have seen. Now let's try to solve one problem statement. What is that problem statement? So, okay, I've written here. Then I've given the solution also. We'll see step by step how we are trying to predict the value. Assuming that we are planning to buy a new house and need to predict the price of the house. So I have already given the area and you have to find out the price of that house. Getting my point? This is a problem statement. Now let's go back to our whiteboard. I will explain what is talking about. Okay. Okay. Guys, I will table. Okay. There is something called area in square feet. I can say, and this is price in square feet. In square feet, and this is price. Okay, fine. Now, for example, I'll tell you. Okay. think about, let's say, starting from 1000 square feet. So price is obviously, let's say, 25 lakhs. So I'm just writing LAK lakhs. So if it will increase, let's say 1000 to 2000, so price will be, let's say, 35,000 lakhs. If it is 3000, then it will be 45 lakhs. If it is 4000, it will be 55 lakhs. That means you are saying there is a relationship between area and the price. Why? Because every 1000 increment, 10 lakhs is increasing. That means per 100, 1 lakh is increasing. So that means if I tell, let's say in between this, let's say I will ask you, see, simple example. For example, I will tell me, what is the price per 1500? Could you tell me what is the price for 1500? If I ask this question, generally, this is what we are going to predict as part of machine learning. I have given certain data sets of lot of rows like area price, area price, area price, area price. Then I'm asking, okay, tell me for 1500 square feet area, what's with the price? So you are drawing a relationship. Oh, when 1000, so let me draw it like this so you get a better idea. Okay, let me draw a line like this. This is my x-axis. This is my y-axis. This is my 0. Let's say starting from 1000. So obviously this will be 500, right? 500. So it will be 1500, then 2000, then 2500, right? Let me scroll up. Then 3000. So I'm just writing 4000, then 5000, then 6000 and all. Okay, similarly here, how much is starting? Let's say 25, right? So let's say, okay, 25 means let's say starting from 5 lakhs, 10 lakhs, 15 lakhs, 20 lakhs, 30 lakhs, 40 lakhs, 50 lakhs, 60 lakhs and all. Okay, 60 lakhs and all. Fine. Now, let me draw. So if I tell 1025 lakhs, so 1025 lakhs, 25 lakhs will come in this point. So can I tell this point is resets here, right? Because this one. Okay, then 2035 lakhs. So here is 2000. So 35 lakhs will come around this 2000, 35 lakhs here. Okay, fine. Now 3000, 35 lakhs, 3000. So 45 lakhs will come like this here. Similarly, 4000, 55 lakhs, 4000, 55 lakhs. It will come like this, 4000. So if I draw a line like this, you can see this is a straight line, obviously, which touches all the point. Because this is a linear relationship. Yes or no? Yes or no? Now if I tell, guys, for 1500 how much? So simply general what happens if you draw mathematically, it will be line like this. So let me use a different color. If you draw line this, it will be touches somewhere here. So 1500 means it will become this one. So if you draw a dotted line like this, okay, it will be exactly touching how much? If I am not wrong, that is 30. So for 15 lakhs, it will be 30. Sorry, 1500 square feet, it will be 30 lakhs. Guys, if you calculate also, just see, as you have seen, every 1000 increment, there is increase in 10 lakhs. Yes or no? So every 5000 increment, there will be increase in 5 lakhs. So 1000 to 1500. So 500 increment. Yes or no? Means difference between 1000 square feet and 1500 square feet. How much? 500, right? So as we have seen, for 10 10 lakhs is increasing. So 5 difference, 5 lakhs will increase. So for 1025. So for 1500 it will be 25 plus 5. So 30 lakhs. So 30 lakhs is coming or not? Even though if you draw like this mathematical also, it was exactly 30 lakhs point. Yes or no? This point, this point. So this is what we are going to predict. So whatever is giving, you are using this for training purpose. Whatever you are trying to predict, this is called predicted value. I can say predicted value. Let me different color. So this is what we are going to predict by using machine learning algorithm. So this is a simple straightforward. Any only two, three rows are there. By seeing this, I can do. But for example, lakhs of records are there. Do you think that by looking into that, I can draw what is the value? No. So I have to train on top of that data set. I have to build a model. Then by using that model, if I give the input saying that, hey, try to predict what should the price for the area 1500. Now my model will give me the output as 30 lakhs, which I will prove it also as part of the last one. Whether 30 lakhs, whatever is giving, that is correct answer or not. That I will prove it. This is very, very important. At the end, I will prove the result. It's not like that blind I will believe, oh, whatever model is giving that is 30 lakhs, that is correct. No, 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 no. Maybe the correct answer is 28 lakhs. Maybe 29.50 thousand. Why I will give extra 50,000 to a builder? For example, you are going to purchase, right? You are going to purchase a flat. So they are telling, sir, we have over 1,025 lakhs, 2,000 square feet, 35 lakhs. So I told, okay, I need a flat of 1,500, 1,500. How much? They told, sir, 31 lakhs. If I pay 31 lakhs, then I am full because the price should be actually 30 lakhs. So they are taking 1 lakh extra as a maybe brokerage amount or kind of, making me fool, whatever maybe, because I don't know math, I don't know machine learning and all. So now I will not believe anybody's word. I will train my model. My model will give me the accurate result. That is, oh, that should be 30 lakhs or 29 lakhs or 31 lakhs, whatever it may be. Getting my point? And that also I need to cross validate it. How to do that? That I will show you as part of my discussion. Till this point, guys, any doubt? Any doubts so far? Then we'll proceed. Any doubts so far? Please let me know. Okay, no doubt? Okay, let me go to my PPT again. Okay, now. Okay, we have seen this one. Now let's do next one. Yeah. Machine learning, terminology we are learning. So we are talking about a feature. What do you mean by that? From a given problem, the feature is area and price. That means, guys, feature is nothing but in a problem statement, whatever column name you are seeing, it may be area, maybe price, maybe location, maybe anything else. Height, weight, temperature, pressure, whatever the column name you are seeing, that is called as each feature. Okay, so here area and price are the feature. Label or target, price of the house. So basically the target or the price which we are calculating, the column for which the value we are calculating, that is called target or label. Apart from that one column, whatever the other column are present, that is called feature. So I can say initially we are telling all these things are feature, like area feature, price is also feature. But generally, frankly speaking, the column for which the value we are predicting. So we are here predicting the value of price, because for this area, what is the price? For this area, what is the price? So we are trying to find out the value for price. So price is called target, or I can say label, and area is called feature. Okay, here's it. Price of the house is called label or target, and area is the feature. So model. A machine learning model is simply a rule or a formula which predict a label from the feature. In this case, the model is the equation we found for the price. What is that prediction? The prediction is simply the output of the model. If the model gives the result as, hey, Guru, I think the house with 3,600, 36,000 area is going to cost $300, then the prediction is 300. That's what I told you, right? For 1500 square feet, I'm trying to find out what's the value. Now, as part of prediction value, I've written also in my whiteboard, it is giving me 30 lakhs. So 30 lakhs here is nothing but my prediction value or the output value. Clear, guys? So now we got different terminology. What is prediction? What is model? What is label or target? What is feature and all, right? So these are the different terminology we learn as part of this simple linear regression. Guys, any doubt so far? Any doubt so far? Now let's move to the next one. So I am drawing this equation or I'm writing this equation from last class onwards. From last class. There's nothing but y is equal to mx plus c. There is nothing but equation of straight line you can see. So if I draw a straight line, it's a blue color line. This is my x-axis, this is my y-axis. The point at which it touches, from that point up to origin, this value is called intercept. So I have taken b or beta 0. Here I have taken, sorry, I have taken c there, right? C or beta 0. Here it has taken b. Green color b is nothing but this value, this value. And what is m is nothing but slope. What is b is nothing but y-intercept. So generally in a machine learning terminology, we are not calling m as slope. We call it as gradient. Remember, these are the different terminology. Last class also we have seen, I have introduced a terminology called gradient descent and cost function. So what do we mean by gradient? Gradient is nothing but this slope. Descent means we are trying to find the optimum value. Getting me a point? So you can see this is a slope. Slope, we are trying to figure it out. So if my equation is equal to y is equal to mx plus c, home price is equal to m into area plus b. If I will try to fit this mathematical, statement or this problem statement into linear model, can I write? Because y is nothing but I need to find the value which is a dependent variable. Depends upon what? X value. Here, what I need to find out? Price. The price depends upon what? Area, square foot area of the house. You can see here. Price I need to find out, which depends upon area only. That means price is nothing but my dependent variable or y, kind of y. Area is nothing but my independent variable or kind of x. That's why I am replacing x and y with the price and area. Then my n value is the same, that is slope, and b value is the same, that is y-intercept. Guys, any doubt so far? Any doubt so far? Please let me know. This is very important, guys, and nobody will explain like this. So please focus. Any doubt, please utilize and ask. So now you are learning in my class how I am fitting a problem statement into a machine learning equation or mathematical equation, because you know y is equal to mx plus c from a childhood, maybe intermediate or maybe high school. You are wondering, general people are telling, hey, we are learning a lot of trigonometry, lot of equation. Where we are using in your life, man? This is the way, this is the place where you are using in your life. This is a practical use case of a mathematical equation. I don't think so till today, you are using anywhere y is equal to mx plus c. But just for knowledge sake or the exam purpose, you are learning, writing and get the mark, you forget. But in the machine learning algorithm or machine learning technique, or I can say part of the machine learning journey, you will learn how to utilize the mathematical equation that we have learned in our childhood. This is a practical real-time example. I'm trying to fit a real-time problem statement into the mathematical model or equation, that is y is equal to mx plus c. So by using this, happily I can predict the price of a house by taking the square feet area. Clear, guys. Now let's move to the next one, guys. So I have taken a data set. Think about this, is a data set. Home price.csv file. In that CSV file, my data sheet is present. Like whatever I'm showing in that tabular format, same data is present. Area and price and data is present. You can see. That's why I've taken the snapshot to save your time. But whatever I'm writing, same things, if you run it as part of your practical, practical session taken by ma'am, then you will get the same output. So just focus on this. Don't worry about that. So I have two different columns. One is area, one is price. So I have area 2,600, 3,000, 3,200, 3,600, 4,000, and its corresponding price also. So how I am reading? For reading, I am using a pandas data frame. pt.read underscore csv. This is a method present in panda data frame, and this is the file inside which this data is present. Now I am trying to just show just 4 to 5 different row. That's why I'm written df dot here. If I write here, just top of 5 row it will display. That's why you can see index starting from 0 up to 4. So 5 row is showing. It does not mean in this file only this 5 row is present. No, no. Maybe 10,000 records are present, maybe 20,000 records are there, maybe 1 lakh record is there. It does not matter. Just for simplicity, I have written here so that I can see some sample data, how it looks like exactly. And to use pandas library, I have to import pandas as PD. Okay, so I'm loading this file. Fantastic. Okay, guys, any doubt so far? Please let me know. Please let me know. Let me see your chat box. Yeah, you can see. Till this point is same. Import pandas as PD. pd.read underscore csv home price.csv. Now what I'll do, guys, I'll try to draw a plot in the xy axis. So how to draw a plot? To draw a plot, Python has provided different library. One library it has provided for matplotlib. So I'm just importing matplotlib.pyplot as plt is nothing but my alias name. Then plt.xlabel area, plt.y label price. What is that? I'm maintaining x label and y label. You can see in this plot, are you able to see there is a label I mentioned here, area. Here written something price. So how it is printing here? In the x-axis it should be area, y-axis should be price. Is it printing? Why? Because I have written here x label A. Put x label as area. It will area. If you put x, it will print there x. If you put y here, it will be shown y here. Not a big deal at all. Now, once done, then in the matplotlib, guys, there are different plots are there. Scattered plot, line plot, bar plot, then a pie chart, histogram, lot of things are there. Here I have written scattered plot. PLT is scattered. Then what I'm doing? df.area. What is the df? Df is nothing but my data frame. So I am taking the column, the value of the column that is area, that is df.area. Again taking the value of the column called price, that is df.price. And I am maintaining what are the data I want to plot in which color, red color. Okay, what is the symbol? So I use star or asterisk or comma, whatever maybe. I am maintaining star. Now you can see happily a beautiful because I have taken only 5 different row. So there are 5 different data points I am getting here. Are you getting my point? Here you can see the symbol is looking star. Why looking star? Why not dot? Because I have taken marker as star. If you mention something else like hash or something else, it will come accordingly. Sir, why red color? Why not green color, blue color, yellow color? Why? Because I have taken color is called red. If you change color is called green, it will be in green color. If you change color is called yellow, it will be yellow color. If you change color is called orange, it will be orange color. That's all. Now I'm happily able to see my data point are scattered across the x and y axis. Getting my point, guys? Any doubt so far? What is matplotlib? What is panda? If you want to know, let me just give a quick introduction also, because anyhow this is not a part of introduction. Guys, you know Python library, right? We are if you know the Python library, then this is very famous in the data science field. Python is a kind of programming language. Programming language. This Python library provides, this Python programming language provides lot of different library, okay, for doing different activity or to achieve different tasks. That is why Python is very famous compared to the other programming language, because this is rich in library. I can say this is rich in library. Okay, rich in library, rich in library support. Okay, what are those library? What are the library? Let me write down few. There is something called NumPy, NumPy. Then there is something called, we have seen, pandas. Then there is something called matplotlib. Then there is something called cborn, cborn. Okay. Then there is something called scikit-learn or sklearn. Okay. Then there is something called, let's say, what else? Boto 3, Boto 3. Then there is something called, let's say, beautiful shop, beautiful shop, SOM, beautiful shop. Okay, then what else? Let me write down few, then I will stop here. What else? What else? Try to recall, try to recall. uh, Pygame, I think. Okay. Py4j, Py4j. Okay, let me stop here. Okay. What are those? Let me write down one by one. Guys, it is given, a library called NumPy. What is NumPy? NumPy is the combination of both numerical plus Python. Python means it is the combination of two different one, that is num py. The first two letter and this is first three letter. Combination is numpy. Numerical Python. For example, you want to do any mathematical operation, kind of little bit complex mathematical operation, kind of playing around the matrices and vector, like matrix addition, matrix multiplication, find the diagonal value, okay, transpose of the matrix and all those things you can achieve by using numpy. Similarly, if you want to go for data analytics purpose, okay, data analytics, analytics purpose, you are using a beautiful library called pandas, generally pandas library or pandas data can. Similarly, if you want to represent the data in the visual diagram, like kind of plotting kind of things, so you are using the combination of both matplotlib, okay, matplotlib and cborn. Okay, matplotlib and cborn. So I can say this is a visualization purpose. Visualization purpose. Similarly, what is scikit-learn? If you want to deal with the machine learning algorithm, just sometimes before we have seen there are two different ways how we can build the model. Either I can use statistical modeling, or there is another way called sklearn, scikit-learn, right? So to deal with machine learning algorithm, machine learning algorithm. Okay, similarly, what is Boto 3? It is also one type of library which is used to interact with the Amazon S3. For example, I want to interact with AWS S3, where I have to store the data. I can interact with it by using Boto 3. So Boto 3 is a Python library. Similarly, Beautiful Soap, it is also a library by using which I can do web scraping. Web scraping, 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 web scraping means to extract the data from the website. You might have seen, right? Generally in the website, for example, newsfeed website, or like any other website, or Amazon website or Flipkart website, if you want to extract the data, that I can extract by using Beautiful Soap. Okay, there's a library name called Beautiful Soap. Okay, now Py4j. So Py4j is nothing but, for example, you want to establish a connection between two different files. One is written in Java programming language, one is written in Python programming language. How they can communicate with each other? For that, you have to use an intermediate library called Py4j. So Py4j stands for Python. Python 4. 4 is nothing but English 4. 4. J means Java. Java. So in short, they are taking the few words that is pi 4J, PY, for FOR 4, they are taking English 4, then J, Java, pi 4J. Are you getting my point? If two files are there, okay, two files are there. For example, the file name is called, let's say, employee emp.java. You have written, sorry, emp.java file. Okay, let's say Java file. Another file you have taken, let's say this is what else? Salary or maybe department.py file. So it's not easy to communicate with each other. Why? Because if both are written in the same programming language, very easy. For example, this is Java, then okay, direct communication. This is Python, okay, direct communication. But here, Java, this file is written in Java, okay, this file is written in Python. So you cannot draw a direct communication between them. You can do it. It's not possible. Then what you have to do? You have to go for a third-party jar file that is called Pi4j. Then the communication will happen through this intermediator. This is the bridge between. Why colors are changing? Yeah, this is the bridge between. This is the bridge between these two different, file. Whatever is written in two different languages altogether. Clear, guys? Any doubts so far? Any doubts so far? So these are the different, I mean, not only these, lot many things are there, I've just highlighted because I cannot write entire 100 library here, right? For your knowledge share. So you might have seen as part of our, code, whatever I'm sharing you. You are saying, sir, has imported, import pandas as PT, import matplot as pyplot as a PLT. Similarly, numpy somewhere you will see in the upcoming classes. Okay, so either you can use matplotlib or Cbon, both are the same. It's a kind of thing about Cbon is the elder brother of matplotlib. Means whatever things are there in matplotlib, little bit higher version in Cbon. But again, both are used for visualization purpose. And scikit-learn today you have seen. So almost today you have seen three different libraries: pandas, matplotlib, scikit-learn. Anyhow, we are not going to use this part of, because we are not using any cloud as part of your journey, right? And anyhow, these are not we are using, but in the upcoming or like in the future, if you want to do such type of activity like web scraping and all, you can use. For your knowledge sake, I'm just giving this part now. And PyPorch also to interact with the Python with the Java file. Clear, guys? Any doubts so far? Right, by using matplotlib, because you can see how this picture is coming is due to PLT. What is PLT? Is nothing but the alias name of the matplotlib. Here you can see PLT is nothing but alias name of matplotlib. Matplotlib.pyplot as PLT. So I'm drawing PLT.scatter, the scatter plot. Then I'm passing the parameter. What are the mandatory parameter? Color, which symbol it should create, like in a star or whatever it may be. Then X value and Y value. Okay, once done, now you can see. Here, I'm writing the actual logic. Guys, as part of sklearn, have you remember, I have written only this line from sklearn.linear underscore model import linear regression. Have you seen? When I was talking about the statistical modeling, when I introduced the sklearn, I have written this line and just one line to create the object of the linear regression, that is REG, is called linear regression. Now you can see the complete code here. How to create linear regression object. Okay, and now I have to import. As I'm reading for that, I'm importing this pandas. This is nothing but the previous code, right? Import pandas as PT. DAP is called pt.read underscore CSV home price.csv. Nothing but this one, right? I also written same things here, right? Same things here. Okay, fine. Now, why I'm dropping, I'll tell you, because I don't want to consider price as my training purpose. So that's a new DAP, it's called DAP.drop price. Now, I have created the object for linear regression. Now I need to fit. Fit means I'm training. Training on top of what? New underscore DF and DF.price. Means new underscore DF contains only area and this contains only price. Why I have segregated in two different parts? Because I need to find out the value of the price by using the area. That's why I have segregated. Because this is my dependent variable, this is my independent variable. Or this is my dependent data or independent data, that is nothing but my area. Now I have just written a print statement like training the algorithm. Once I run it, execute it, I'll get a confirmation message saying that yeah, training the algorithm. So model training has been done. Now let's move to the next one. That is predict price of a house with area 3,300 square feet. Yes. See. Now till this point is same. 1, 2, 3, 4, 5, 6. First 6 line is the same as the previous line. 1, 2, 3, 4, 5, 6. You can see. Same. Same. I have reused so that you will feel comfortable that I am not writing any heavy lines of code in one class. Just one line I have added. Try to find out the prediction. How to predict? There is a method called predict. Then I need to pass. What is this 3,300? It's nothing but area. So I think about, I'm trying to find out, tell me the price of a 1,500 square feet. Like in the whiteboard I have explained. So it is giving output as 30 lakhs. Now here giving output as you can see around 62 okay, 6 lakhs 28,715.75 something. Now, this predict method I'm calling on top of what? REG. What is this REG? It's nothing but the object of linear regression. So whatever function or method you are seeing here, feed, predict, and all, that I'm using on top of the object. That is why it's highly recommended to create the object of a linear regression. Without creating the object of linear regression, you cannot use this kind of method or a function. That is the interview question. Why you want to create object of a linear regression class? Because, sir, if I have to train the model or further find the prediction of the model, I have to figure it out on top of the linear regression object itself. Because you can see reg.fit, reg.predict, all the things I am doing on top of the reg only. If I don't create, then how to do that? How to do that? Now let's move to the next one. Capture the coefficient from regression, you can see. Okay, again, you can see. Okay, you find out the value. What's the value? 62,807.15. Okay, now let's stop here. I will prove it, guys. You no need to do anything. Guys, clear or any doubt? Okay, let me go there. Look, it's very interesting. Last moment. Yeah, you can see. Next, yeah. Capture the coefficient from regression. Guys, see. 1, 2, 3, 4, 5, 6. First 6 line are same as previous one. I am not doing anything. I am making your life very easy. See, 1, 2, 3, 4, 5, 6. Same or not? Just the regression fit new df df dot price. Same thing you written or not? Just I am writing one line. Print regression reg dot coefficient. So I am getting coefficient value. It's nothing but this is my beta value. What is the beta value? 135.78767123. That's all. Guys, it's very much interesting. That's why I'm telling you why I'm creating the object of linear class. Linear regression I'm creating object. Why? Because whatever process I'm doing, reg.feed, reg.coefficient, reg.predict, everything I'm doing on top of the regression object, linear regression object only. So I find out the beta 1 value, that is 135.78767123. Fantastic. Similarly, can I find out the intercept value? Intercept, same. First 6 line are same. Import statement, this one. Now just one line. reg dot intercept underscore. Here reg dot coefficient, COEF, coefficient underscore is giving my beta 1 value. Here reg dot intercept underscore, it is giving me beta 0 value. Now guys, I got my beta 1 value. I got my beta 0 value. Beta 0 value here. If I put in the equation, that is y is equal to mx plus c. So m value is my coefficient, means beta 1. Area is giving, that is 3,300. Beta 0 intercept, I got it, this value, bigger value. 180,616.43383561 blah blah blah. There you can see. I've written also for your knowledge. Intercept I got this one. For coefficient I got this one. Coefficient nothing but slope, that is n. Intercept nothing but here my b value. If I put in this equation, guys, see, y is equal to mx plus c. M is the coefficient and beta is the intercept. Let's calculate the above formula. In the given formula, m is coefficient, beta is intercept. Now put m value 135.78767123. Where I'm getting? Here. Coefficient, right? Then intercept into 3300 means nothing but my x is nothing but a given area. Now, what is my y value? Is nothing but, sorry, what is my beta value? Is nothing but my intercept. That is nothing but here. Intercept 810.616.4380 something that I'm putting here. Guys, if you calculate this, if you multiply this equation with this, I mean 135.78767123 into 3300 plus this one, you are getting output as 628,715.75342466. Guys, you see whatever I pinned on the chart or whiteboard is exactly matching the same or not? Exactly matching the same or not? Let me come back to your whiteboard and I'll just write down. Clear, clear, guys.